Hello and welcome. In this video, we're going to be going through part 2 of the sketching functions series. This series I designed with number of steps that if you follow correctly, you will be able to sketch any functions. In part 1, which is very important, I will leave a link to it on the top right hand corner. I went through the first 2 steps over here, finding the domain of a function and locating x and y intercept. In this video, we're going to be focusing on determining vertical asymptotes and holes. So first of all, before knowing how to determine them, we need to understand what is a vertical asymptote. Okay, let's say we have y and x, and we have a function that looks something like this. Let's say something like this. Okay, so I can see that there is some value here. Let's say this is x equal 2, where if I drew this dashed line over here, I can find that my curve is always approaching that line, coming very close to it, however never touching it. Okay, as well as from the other side, the curve is going to keep on going very close to this line, however it will never touch this line or cross it. This line is called an asymptote, and since it's vertical, it's called a vertical asymptote. Again, we have a horizontal asymptote, which you can guess is the exact same thing, a line where the curve will never intersect. Okay, however this line is horizontal, so this is called horizontal asymptotes. So basically, vertical asymptotes occur at points, so in this case at x equals 2, where the function is undefined. There is no value of y whatsoever on this curve when x is 2. So what makes a function undefined at a certain value? Let's say we have a function y equals 1 over x minus 2. So if x is 1, I don't have a problem. If x is 3, I don't have a problem. What if x is 2? If x equals 2, then y is going to equal 1 over 2 minus 2, or is going to equal 1 over 0. And anything over 0 in mathematics is undefined. I cannot divide anything by 0 in mathematics. So that's why at x equals 2, my function becomes undefined, and then a vertical asymptote arises. Okay, so if I told you what is the vertical asymptote of 1 over x, okay, so y equals 1 over x, you would tell me I cannot have the denominator as 0, so 1 over 0. So x, when x is 0, that's a vertical asymptote or an undefined point. Okay, what about 1 over 3x plus 3? So again, I cannot have the denominator as 0, so if I want to find that point that will cause undefined function, I'm going to equate the denominator to 0 to find x. So this is going to be 3x equals minus 3, x equals minus 3 over 3, so x equals minus 1. And when x is equal to minus 1, I will have my function undefined, and this will cause a vertical asymptote. Okay, so let's try to erase this. Let's say we have again this function f of x is equal to 1 over x minus 2, and I ask you to find me what point is going to make this x undefined. So what x is going to make this function undefined? You're gonna tell me, okay, I'm gonna set my denominator to 0, because x that will cause my denominator to be 0, that is the x I don't like. This is the x that is going to make it undefined. So if x minus 2 equals 0, simply x is equal to 2. Okay, so you tell me this is the vertical asymptote. I tell you you're right. Okay, let's say we have another function, g of x, and this function is now equal to x squared minus x minus 2 over x minus 2, and I ask you the exact same thing. What is the x value that's going to make this function undefined? You're going to do the same thing. Denominator cannot be 0. X minus 2 equals 0, so x equals 2. You will tell me that x equals 2 is going to cause this function to be undefined. Up until here, I'm going to tell you you're correct. However, if you told me that x equals 2, this is the vertical asymptote, I'm going to tell you no, you're wrong over here. The point I'm trying to make is not any x that's going to make the denominator 0 is going to be a vertical asymptote. Any x that's going to make the denominator 0, it's going to be undefined. Yes. However, we have different types or shapes of undefined. One of them is vertical asymptotes. Let's see what else do we have. So over here, I graphed these two functions. So if we copied them, if we copied these two functions, okay, over to here. So let's put it over here. So this is f of x and this is g of x, okay? And as you can see, both of them are undefined at x equals 2. So when x is equal to 2, okay, here I have an undefined, I don't have an actual value, okay? And over here, if you look, I also have undefined. However, the difference is that in f of x, the one on the left, I have a vertical asymptote, okay? This is one type. The second part, I have something that's called a hole. And it's very, very self-explanatory. You basically have a line or a curve, and there is literally one point that is undefined, and then the curve continues as if nothing happened. So these are the two types of scenarios that you will find when you have an x that will cause your function to be undefined. So my goal from this video is to show you how can you find if it's a vertical asymptote or if it's a hole. Okay, I'm gonna give you a very, very simple rule. So let's get back to our g of x and f of x and let's try and see what's the difference. First, let me try to factorize g of x. This is a quadratic, it's factorization, two factors of 2 that will subtract to 1. So they're going to be 2 and 1. So this is going to have x times x. This is 2, this is 1. By the way, I did a full playlist on quadratics. I'll leave the link to it on the top right hand corner. This is going to be minus, this is going to be plus over x minus 2. I did nothing but just to factorize the numerator. Over here, I can see something interesting. I can see that x minus 2 and x minus 2, which is the factor that caused me to have an undefined part, it's shared. So we have a shared factor between the numerator and the denominator. Okay, so when we have a shared factor, that is the cause for a hole. Okay, so since they both share a factor, the numerator and the denominator, since there is a shared factor, then this x, which is 2, no longer gives me a vertical asymptote, it gives me a hole. Okay, is that always the case? Yes, but we have some differences. Okay, if the shared factors have the same degree, so this is 1, this is 1, they cancel equally, it's a hole. So let's do our rule. Shared factors, if they are equal degrees, so the powers are equal, then it's a hole. Okay, if the numerator degree is greater than the denominator, okay, then this also is a hole. Okay, however, if the third scenario, if the denominator degree is greater than the numerator, then it's a vertical asymptote. So this is basically the common rule that we have. Over here, we have a shared factor. So this might be a vertical asymptote or a hole. We don't know. We need to check the degrees first. They're both equal degrees, so this is a hole. If this was, let's say, x minus 2 power 2, okay, then the numerator degree is larger than the denominator degree. It will also be a hole. However, it's going to be the second scenario. If the denominator, let's say, was to the power of 3, Okay, that means that the denominator power or the denominator degree of the shared factor is greater than the numerator, so we will have a vertical asymptote. This is basically the rule that we will follow from now on, and there is nothing more you can know. Obviously, if we do not have a shared factor, no shared factors, that means that the denominator degree is higher, because the numerator degree, we don't have anything in the numerator, it's not shared, so this is also a vertical asymptote, like in this case over here. We do not have any shared factors, we just have x minus 2, no x minus 2 on the top, so this is a vertical asymptote. Let's take some examples to see how this works. So let's say first we have f of x equal to x cubed minus 2x squared over x squared minus 3x minus 18. So the first step, okay, to know if we have shared factors or not, is that we need to fully factorize the numerator and the denominator if possible, if they're factorizable. And here they both are. So over here, I'll take an x squared out from the top. So x squared, I'll be left with x cubed divide x squared, that is x, minus 2x squared divide x squared, that is minus 2. So this is the top factorized. The bottom is a quadratic, so I will go through factorization. I need two factors of 18 that subtract to 3, which is 6 and 3. So this is going to be x, 6, and 3. The larger one takes the middle sign, so this is going to be minus. This is plus. So over here, let's see the points that's going to make my function undefined. Anything in the denominator that will cause the denominator to be 0 is an x that will cause my function to be undefined. So over here I have if x minus 6 equals 0, so x equals 6, and if x plus 3 equals 0, the whole denominator becomes 0, the whole thing becomes undefined. So if x equals minus 3, that will cause all of that. So I have these two points. Now I know for sure that these are points where my function is undefined. Now I need to determine either a vertical asymptotes or holes. Over here, do I have any shared factors with x plus 3? No, so this is a vertical asymptote. Do I have any shared factors in the numerator or denominator with x minus 6? No, only in the numerator. Do I have any shared factor, any x minus 6 in the numerator? No, so it's also a vertical asymptote. And over here, I graphed this function so we can take a look and confirm our findings. So we said that if x equals 6, that will be a vertical asymptote. Oh, this is minus 3x. So this should be minus. I do it plus. So over here, we will have if x equals 6, which is this black line, we can find that it is indeed a vertical asymptote. Okay. And the second value was when x is equal to minus 3. So when x is equal to, and I can see as well that this is a vertical asymptote where my graph is going to keep on trying to get close to it, but they will never touch, just like when x was equal to 6. So these two are indeed vertical asymptotes, and my solution is correct. So let's take another example. Let's say we have f of x equals x squared minus 2x minus 24 over x minus 6. So as of now, I know straight away that if x is 6, then it's going to be undefined, but I don't know if there is an x minus 6 in the numerator that will cancel with this x minus 6, so to make it a whole. So the first step always is to factorize your numerator. So let's do that. I will need two factors of 24 that subtract to 2. These factors are 6 and 4, so I will have x, 6, and 4. This is going to be minus, this is going to be plus over x minus 6. And over here, just as we were afraid that would happen, we have a shared factor. So x minus 6 will cancel with x minus 6. So over here, I know that when x equals 6, since they are shared factors, since they have the same degree, x equals 6 is now a whole. And let's confirm that. So let's graph this function, x squared minus 2x minus 24 over x minus 6. And let's try to see what happens when x is 6. And indeed, as you can see, when x is 6, my function is undefined and there is a hole. It's no longer a vertical asymptote because of the shared factor. Okay, let's take another example. Let's say that we have g of x equals 4 into x plus 5 times x minus 2 over x squared minus 4. Again, let's fully factorize the denominator. So this is going to be, this is difference of two squares. So this is going to be square of the first time plus square of the second times square of the first minus square of the second. And over here, what are the two values that will cause my function to be undefined? X equals minus 2 from this factor and x equals 2 from this factor. However, I can see that x minus 2, okay, is cancelable with the numerator and they both have the same degree. So this is going to be a whole. However, this has nothing to cancel with, so this is normally a vertical asymptote. So we'll have a vertical asymptote at x equals minus 2 and a whole at x equals 2. Let's try and confirm that. So at x equals minus 2, we indeed have a vertical asymptote, and as much as we try to go down for these blue and green lines to meet, they will never ever meet. And again, if x was equal to 2, we should have an undefined function. However, it's in the form of a whole, so we can confirm over here that this is indeed a whole. Let's take one more example. Let's say we have the function f of x equals x plus 2 over 3x into x plus 2 squared. So over here, this is fully factorized. There is nothing I can do. The values that will cause the denominator to become 0 are x equals 0 from this 3x part and x equals minus 2 from this part. However, I can see that straight away the 3x, so this part has nothing, has no 3x to cancel over here. There is nothing that in that sense, so this is literally a vertical asymptote. However, here I can see that I can cancel x plus 2 with one of those x plus 2's inside. So over here, I have a shared factor. However, I need to be careful that they're no longer the same degree. The denominator is a higher degree, so this should be a vertical asymptote. If the numerator was a higher degree, let's say this was power 3, so now I will cancel as well. However, this will cause a whole, not a vertical asymptote. But in this case, it is not. So let's check. So we're supposed to have a vertical asymptote at x equals 0 and a vertical asymptote at x equals minus 2. Let's check if that is correct. So x equals 0 is this line and x equals minus 2 is that line. However, if I can draw, yeah, this is much better. Over here, I can see that at x equals 0 and at x equals minus 2, indeed, I have vertical asymptotes. So I hope you benefited from this video. I hope you go check the previous part and you subscribe to not miss the other parts. And then at the end, I'm going to be doing multiple videos where I combine all these steps and parts that you already saw to solve fully sketch functions in front of you and teach you how to sketch any function. Anyways, thank you for watching. Hope you have a nice day. Don't forget to like, comment, and subscribe. Thank you again.